Alright, so here we are for lesson 5 of algebra, and in this lesson we are covering factors and absolute value. And this is going to cover up and end our section on words that are important to know to do algebra, which I think hurrah, because learning all the words to do algebra I think is the most boring part of doing algebra. But it's somewhat important, so we're going to finish it out. Now remember, in the last class we learned three new words. They were terms, like terms, and expressions. And if you can remember what all those are, we're doing pretty well. And the last two terms and words that we need to know for algebra are factors and absolute value. So let's look at factors first. Hopefully you're familiar with factors from some sort of pre-algebra course or even just multiplication and division. This is nothing really new, but we're just going to cover it again. So a factor is numbers being multiplied. You can also consider it like if you have the number, let's do the number 30. What is the number 30 made up of if you're doing a multiplication problem? Well, if you're doing multiplication, you could make the number 30 several ways. You could make 30 out of 15 times 2. So both 15 and 2 could be factors of 30. Well, you could take it even farther if you wanted to. You can make 30 out of, sorry, that was wonky 30. You can make 30 out of, well, 15 we can split into even further factors. You can make 15 out of 5 times 3. So if you wanted to make 30, you could do 5 times 3 times 2, and that would equal 30. These are the base factors of 30, but we can make 30 a different way. Let's make 30 a different way. 30 could be made out of 3 times 10. So 3 and 10 could be factors of 30. But then once again, we could split 10 down into some further factors. So we could break it down into 5 times 2 equals 10. And once again, 2 times 5 times 3 equals 30. So in the end, we got all the same base factors that could make 30, but we could also do it in 2 different ways. 3 times 10, 15 times 2. We have a couple of options. So factors are anything that can be multiplied together to make up a greater whole. Or if you're looking at it the opposite way, you can break down a bigger number into its smaller factors. So that's a factor, that's a factor, that's a factor, that's a factor. If we want to do an even bigger problem, we could say that 30 is a factor of 90, right? Because 90 would be made up of something like 30 times 3. And so 30 is a factor of 90. So almost any number, basically any number can be a factor. It just depends on what your big number is that you're dealing with or what multiplication problem you're doing. Alrighty, so that's factors. Let me get rid of all these 30s. Alright. Alright. Another important word to go along with factor is product. So if you're doing a multiplication problem and you're doing 3 times 5, which equals 15, as we recently discussed, then your factors would be 3 and 5. Those are both factors. Factor. I'm not going to write it all out. You know what that means. And then this, 15, would be the product of multiplication, which hopefully you're familiar with from, like I said, just basic multiplication facts, but just a reminder that this would be the product. All right, moving on, we can do some fancy factors, and I don't want to get into this too much because it's like the basis of most of algebra, but let's look at a couple fancy factors. Okay, so we have this. 7AB. This is a problem that contains 3 factors. Can you name them? Hopefully you named that 7 times A times B is what we're dealing with here, so all 7, A and B, are all factors of this problem. Let's look at another one. Let's say that we had, let's go over here, say that we had 5x plus, 3. Okay, that's one term. We're multiplying that by 2x plus 3. That's our second term. And these are both factors because they're being multiplied together. And then our end result, or our product of this, would be 10x. Oh, I need a squared. I don't know how to make a squared. Hold on. 10x squared. Okay. Ah, that died. Guess gotta write it all out. 10x squared plus 15x plus 6x plus 9, which you will eventually learn how to do, but don't worry if you don't know how to do that yet. But anyway, the point is that this is a factor, and this is a factor, and this is the product of those 2 factors. And in a lot of algebra, we're going to be taking giant products like this and breaking it down into its smaller factors so that it's easier to figure out exactly what x is. But don't worry, we'll get there, and it won't be scary by the time we do. All right, so moving on to absolute value. Now, absolute value is an interesting one that you don't totally need to know for algebra purposes. They will come up in algebra problems just because they want to remind you of what absolute value is, but the real reason that you need to know absolute value is for things like statistics and recognizing how to read studies in the future, which will be crucial if anybody goes to college or wants to understand how to read a study. So absolute value, let me just get rid of these. Done. Absolute value. Let's see. All right. So absolute value is a term that explains what we do when we just want to know what the value of a number is. And we don't want to know whether it's negative or positive, we just want to know the quantity value of it. For example, the absolute value, okay, here we go. The absolute value of -7, and absolute value is written with these giant lines on either side of a number. Absolute value of 7 equals 7. So basically, if you have a negative number inside of an absolute value sign, once again, absolute value sign is referred to as these giant straight lines. Unfortunately, mine aren't very straight. Sorry about that. But the absolute value of -7 is +7. And the reason for this is that when we're looking at absolute value, if we're looking at on a number line, we could have, this is 0, a -7 over here, boop, +7 over here. And we just want to know the value of the number that we're dealing with, or how much of the number we have. So in that case, the value of the number is 7. Doesn't matter that it's negative, doesn't matter if it's positive, the value of it is 7. It means we have 7 things, $7, 7 pencils. That's what we're dealing with. So the value is 7, and therefore the absolute value is just 7. So let's do another problem. Dun, dun, dun. Ah, it's moving. Let's say we have all right. Let's say we have these set of problems. What does that one equal? I'll let you work it out while I write some other problems. All right, So we have 3 problems here. First problem wants to know what's the absolute value of -3. Well, the value or the number numerical option is 3, so the answer is 3. A standard rule is just if you have anything within an absolute value, no matter if it's positive or negative, it always comes out positive. So you can remember it that way, or you can remember the value of it. Absolute value of 7xy. Well, in this case, it's just the value of those numbers and letters. Now, we don't know what x and y are, but we don't need to. We can just know that we just care about what the eventual number is. If this problem had been like problem 3, the absolute value of -10bz, well, we just want to know the total value numbers, and so it's not going to be negative anymore. It's just going to be 10bz is our answer. So pretty easy to deal with the absolute value. Not too difficult at all. Now you might be like, okay, but like, why does this even matter? And let me show you why. Dun 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 dun. If I can. Sometimes this computer doesn't like to work for me. All right. The reason you care about absolute value is because when people are doing studies on any sort of thing, they are doing a set of statistics that deals with what you might call this bell curve. And you'll see this bell curve in a lot of places in the future, especially if you do any sort of college work where you need to look up a study. Now in this bell curve, it tells us that the center middle portion of people, and this is typically the portion of people from numbers -2, because of how they do the math, to +2 on the number line, are average. So let's say that these are the people who like hamburgers. Actually, let's make them omnivores, right? So they eat both plants and animals. Okay? So these are plant and animal eaters. Omnivores. And that's the average person, right? The average person is an omnivore. They eat some vegetables, they eat some meat, they eat some dairy. Omnivore. Doesn't really matter. Okay, but we want to do a study on the people who aren't normal. In other words, we want to do a study on the people over here who are vegan, don't eat a single thing that comes from an animal. And we want to do also research on the people over here who are carnivores and never eat a single thing from a plant, which doesn't sound very healthy to me, but let's look at the two extremes, right? So when we're doing this, we want to look at the set of people that are within this range of 2 to 3 usually, or -3 to 2. When we're doing that mathematically, obviously the numbers themselves, -3 and 3, are opposite of each other, but if we take the absolute value, that we're going to look at a group of people between the absolute value of 2 and the absolute value of 3, and that's our range, well then it's easy because the absolute value of 2 to 3 is, we can look at this group, and then it doesn't matter if we're looking at this side either, we can look at that set of values too. So it could be the absolute value of 2 to 3, it could be the absolute value of -2 and 3 and -3, and we'll be looking at those set of people that we want to be looking at. Hopefully I've explained this in a way that makes sense. Sometimes things don't come out of my brain the way I hope they do. But basically, when we're looking at this, we can use the same numbers to calculate things, but we can be looking at the vegan side if we're doing the absolute value of -2 and -3, or we can be looking at the carnivore side if we're looking at the absolute value of 2 and 3. It basically means that we can work with the numbers exactly the same, but be looking at two different groups still. Hopefully I clarified that. If I didn't, I apologize. Reach out with questions if you want to. But anyway, that is where you would use the absolute value. That's why it matters, because in this type of statistical problem, we need to be looking at a certain value set, but they're sometimes going to be on opposite sides of this, this number line, where we have this side over here that's not normal and the side over here that's not normal, but the numbers that we're dealing with are the same. Hopefully I clarified that. Once again, I'll see you in the next video.